All right, now, yesterday we learned that, all right, we had what? X squared plus 14xy plus, what was the last thing? Was it this? So we found out that this was x plus okay, so now you got to look at patterns here. All right, you got to look at patterns here. This is x squared plus 2 times your x term times your y term, right? Plus 7y squared. So in other words, we had a squared plus 2ab plus b squared. So could you figure that out from your guy?
Yes.
You know what I mean? Like if you put your, whatever they gave you, under this, could you figure this out? I think you could.
Yes.
You could figure out what A and B have to be. I want you to think about it. I don't want to just give you the answer. Okay, I want you to think about the pattern. Okay, this was it was in the B spot, and I had to say 2 times my A guy times my B guy. So you kind of look at your guy and see what you can figure out. Okay? Okay. Any other ones?
No.
Was that the only one? Most of the other ones you got? Okay, so what we're going to do is today, we're going to do basic trig identities. On Friday, today's Wednesday, yes?
Yes.
On Friday, we're going to have a quiz on the basic trig identities. Quiz, it's like a 20-pointer. And it's a right or wronger. Either you got it or you don't. Either you memorize it or you didn't. Okay? It's mean. I'm going to be mean. Because I want you to memorize. And mean works. That's the only thing that works. All right. Now, some of you are going to like this. Some of you, as we learn about these identities, this is the deal. It can be so much fun. This can be like a little puzzle. I'm a puzzle person, okay? I'm one of those people who has a puzzle out on like a dining room table, and I'm always walking by and putting pieces in it. I'm also one of those people who every day in the morning I do the crossword. It's 2 crosswords and there's the 7 little letters, 7 little words. Okay? And I try to time myself so that I have like 20 minutes. 20 minutes to 25 minutes I have to do all of them. Okay? So, my biggest hang up with them is I can't spell. Other than that, we're good to go. Okay? So, I am really bad at spelling.
I'm just bad at
Okay, I'm a sight speller. I look at it and I can say, Emily, you spelled that wrong. Can I tell her how to spell it? No, I just know it's wrong. You know, that's weird, but it is what it is. Okay. If there's ever a time that you want to change desk and move, you can. Okay, you don't have to stay in the back. You got notes? Everybody's got notes? Okay. You have some?
Yes, I do have some.
Okay, now, we have, factor completely. We're going to quick just do a factor completely guy here. And then we're going to talk about these identities, and believe it or not, you know some of these already. Okay, how do we factor this? This is 1 minus x times 1 plus x. And every day, all of us who are doing advanced pre-calc will probably practice a little bit of factoring, because when we get to trig equations later on, you have to know how to factor, or you're really in trouble, okay? Because you won't be able to solve the equations, all right? Okay, so I'm thinking I've got to have a 3x on one of them and an x on the other, Because the only way to get a 3 in the front would be 3 times 1, right? Okay, now, somehow magically, I have to get a 5. So, and 2 is 2 and 1. So we just have to figure out the combination. And by the way, he is a plus 2, so both of these, since the middle guy is negative, both of these would have to be negative. And I think it has to go like this and like this, so that I get 3x and 2x and get the 5 in the middle. Okay, now, reciprocal identities. We know, and we truly should know this, that the cotangent is 1 over tangent. The tangent is 1 over cotangent. Secant is 1 over cosine. Cosine is 1 over secant. Cosecant is 1 over sine. And sine is equal to 1 over cosecant. Okay, now, next thing is there anybody in here who hasn't had their picture redone? Okay, because I know that's where he went to go get his picture retaken. And I don't know when they give you a chance to do that. Okay? Alright, now, quotient identities. Tangent is sine over cosine. Cotangent is cosine over sine. Well, guess what else? If tangent equals sine over cosine, and if sine is equal to 1 over cosecant, isn't it? And cosine is equal to 1 over secant. So wouldn't tan also be equal to secant theta over cosecant theta? Yeah, I mean, that's kind of cool, but that's we don't see it often, but it could be. Okay, that means then that cotangent is equal to cosine over sine. Cosine is 1 over secant. And sine is equal to 1 over cosecant. So then cotangent is equal to cosecant theta over secant theta. I just want you to know that if they had something like that, it's not like, oh, well, how did they get that? Okay, then we have these guys, the Pythagorean identities, and you're like, well, how in the heck did they get that? Okay, well, I'm going to show you how they got that. If I know that all of you know this. You know that x squared plus y squared is equal to, r squared. Correct? Mm-hmm. You're all good with that?
Yes.
Okay. How about if I divide everybody by r squared? Everybody. I'm going to divide everybody by r squared. So I'm going to have this guy divided by r squared, this guy divided by r squared, this guy divided by r squared. Okay? Okay? So now I'm going to write x over r squared plus y over r squared equals 1. What's x over r? That's cosine. So I have cosine theta squared plus y over r is sine theta squared equals 1. So they write this like this. Now, when you go to put this in your calculator, and eventually we will put some of these in our calculator, you cannot put this little 2 in between your cosine and the angle. You have to put it in your calculator like that, with the parentheses around it, okay? Okay, and this does not equal this. This is saying take the cosine of 60 degrees and square it. This is saying take your angle 60, square it, and then take the cosine. Okay, be very careful. This is a big no that people do all the time. Okay? Now, so look at that. We got this first one. We got this. See, it didn't just come out mysteriously. They said, poof, here you go. They really did do this little proof here and figure this out. Okay, now, if I know, and see, I am so used to writing this with sine first. I'm going to rewrite it with sine first. If I have sine squared theta plus cosine squared theta equals 1, if I divide everybody by sine, everybody, what do I get? If I divide everybody by sine squared theta, sine squared theta divided by sine squared theta is 1. Cosine over sine is what? Cotangent, and since these are squared, this is squared. 1 over sine, that's cosecant, but this is squared. So I get 1 plus cotangent squared equals cosecant squared. How about that? Look at that. Right there. One of the Pythagorean identities. All right. Well, what if I started out again with sine squared theta plus cosine squared theta equals 1, but this time I divide by cosine squared. Well, what's sine over cosine? Okay, but these are squared, so I get tangent squared plus 1 equals 1 over cosine is secant, but this is secant squared theta. Aha! Look at that. That's the other one. Okay. So, now, I want you to know something. If I take sine squared theta plus cosine squared theta equals 1. There's many ways to write this. I can say cosine squared theta equals 1 minus sine squared theta. I could even say, if I wanted to get crazy, cosine theta equals plus or minus the square root of 1 minus sine squared theta. Somebody else might come along and say sine squared theta equals 1 minus cosine squared theta. And might even get crazier and say sine theta equals plus or minus the square root of 1 minus cosine squared theta. I just want you to know all those different ways are okay. Okay, that's just what? That's just an equation. I'm just moving stuff around. Do I need to memorize all 5 of them? No, if I know the first one, I know the other ones by just moving stuff around, right? I mean, don't waste brain cells, okay? We just need one to memorize that one guy. In fact, you'll see me do this all the time because I'm really, I know you all think that I'm really not lazy, but I am. Because you'll see me write something like this. S squared plus C squared equals 1. I'll say, ooh, if I divide everybody by S squared, I get 1 plus cotangent squared equals cosecant squared. Or if I have S squared plus C squared equals 1, and I divide it by the C's, I would have tan squared plus 1 equals secant squared. Because you know what? I didn't want to bother memorizing them. I just memorized the first one, and I just figured the other ones out all the time. Okay? Lazy, I told you. Lazy. Okay? Okay, now let's go on to do these odd and even identities. We have talked about these once before also. We know that because sine, cosecant, tan, and cotangent are all odd functions. How do I know? Because when you do f of negative x, you get negative f of x. That's odd. That is, you are flipping over the origin. Okay, you're flipping over the origin. If you're going from 1 to 3 or 2 to 4, flipping over the origin. Okay? And if you're even, then f of negative x equals f of x. This is even, and that is cosine and secant. Why? They flip over y. They're symmetric with the y-axis. That's what I mean by flip over. They're symmetric with the y-axis. This is, some people just have to memorize these. I know that sine and his buddy and tangent and his buddy are odd. That's how I remember it. And cosine and his buddy are even. Okay? All right, now, they're asking me to do a few other things here. Okay, they asked me to, okay, this is sort of a review problem, this next one. We've done this before. We're smarter than this. Okay? They're telling me that this paperclip is giving me, not paperclip, staple, it's giving me a run for my money here. It does not want to come out of the paper. But you can't put it through the printer later, otherwise it goes it makes a strange noise. Okay, it says cosine of theta is equal to 5/8 and theta is in the fourth quadrant. Okay, I got this. I'm going to draw the picture. I've got my angle here. Cosine is 5 adjacent over hypotenuse. Right? Cosine equals adjacent over hypotenuse. And cosine is positive in the fourth quadrant. Don't I need to find the y guy? How would I get that? Could I say h squared minus 20, okay, h squared minus 5 squared? 64 minus 25? What is that? 39. Yuck. Negative radical 39. Why did I make it negative?
Because it's below the x-axis.
Right, because it's going down, exactly. All right, so what is the sign? Sine is negative radical 39 over 5. No, over 8. Bad mistake. Over 8. And tangent is, there's the one I just did. Tangent is opposite, negative radical 39 over adjacent, which is 5. Okay, what is secant negative theta? Well, that is what? The same as secant of theta, is it not? Yeah. Because cosine and secant are even. So that means that secant is equal to what? 8 over 5. Yay, team. Okay. Next. Express tan theta in terms of cosine theta. Uh-oh. Well, I know that tan of theta is equal to sine theta over cosine theta. But they're saying they only want cosines. Well, wait a second. Let me go back here. found out that sine squared theta was equal to what? 1 minus cosine squared theta, right? Well, isn't sine theta then equal to plus or minus the square root of 1 minus cosine squared theta?
Yes.
So couldn't I write this? Isn't that all cosines?
Yes.
Yes, it is. Well, that was easier than I thought it was. Alright, then we have write secant plus cosecant in terms of sine and cosine, and then simplify the expression. We got this. We are smarter than they are. Okay. Secant is 1 over cosine. Cosecant is 1 over sine. Isn't that like 1/3 plus 1/7? Don't we just need a common denominator? Okay, so this guy is cosine on the bottom, but what would be a common denominator? If you had this, how would you get the common denominator? You multiply them. So what are we going to do with these two? We're going to multiply them. So we're going to multiply this guy by a sine on the top and a sine on the bottom, right? So I got sine theta over sine theta cosine theta. This dude needs a what?
Cosine.
Correct. He needs a cosine. So I get sine theta plus cosine theta plus, notice it's a plus. On the bottom, though, they're doing what?
Multiply.
Multiplying. But that's as good as it gets. That's as simple as it gets, isn't it? Okay, we're good. Anything you can do with this, it's just like when you have 1 over x plus 1 over y. I think when you guys see sines and cosines, you freak out. You just don't think of them like regular, plain old things. Okay? Okay, let's see what we got here. If tan of theta is equal to 4/3, and I'm in quadrant 3, okay? If tan of theta is equal to 4/3 and we're in quadrant 3, well, how can that be? Shouldn't this be negative 4 over and a negative 3? If I'm in quadrant 3? Okay. Now, what's the hypotenuse? Okay, the hypotenuse or the radius is never negative. He's always positive. So I'd have negative 3 squared plus negative 4 squared would be 9 plus 16, or the square root of 25, which is 5. Or some of you just have that one memorized. Okay, now what is secant equal to? Is equal to hypotenuse over adjacent, or it's equal to r over x. So I have 5 over negative 3. Ew. Okay, tan theta equals 2.6. Tan of negative theta is equal to negative tan theta, right? So, tan of negative theta would be equal to negative 2.6. Okay. True or false? Oh, how could you figure that out?
True.
Okay, how can we figure it out?
Because it's
How How do you think we should figure it out?
Oh wait, no.
Okay, now,
It's one of the Pythagorean theorems.
is it a Pythagorean identity?
Yes.
What?
Or almost, actually.
Well, wait a second. These are the Pythagorean identities I know. Sine squared theta plus cosine squared theta equals 1, right? I know that tan squared theta plus 1 equals secant squared theta. 1 plus cotangent squared theta equals cosecant squared theta. Those are the guys I know. Okay, so what is this? 1 plus, I don't even know if that's any one of them.
I don't think so.
No,
No,
it's
it's
not.
false.
Okay,
It's false.
this is tan squared theta equals 1 plus sine squared theta. I think that's a no.
It is not.
Okay, so this is a false. Alright, what if you didn't believe Andrew when he said false? How else could you do this? You know what? Pick an angle. Think about it. Pick an angle. See if it works for the angle. I'm going to say 30 degrees. Sine of 30 degrees squared over cosine of 30 degrees squared equals 1 plus sine of 30 degrees squared. Well, what is the sine of 30? Oh, Miss Seymour, I memorized them. That's a half. What is cosine of 30 degrees?
0.6.
Radical 3 over 2. Just saying. 0.866. Okay, so I have over here, I have 1/2 squared over radical 3 over 2 squared. Is that equal to 1 plus 1/2 squared? I've got 1/4 divided by 3/4. Is that the same as 1 plus 1/4?
No.
Correct. 1/3 does not equal 5/4. Okay? So you could do it with an actual angle. Okay, now what are we going to ask you to do for homework?
Have a sign of this
Puzzles.
one. Puzzles.
We can do a couple together if you want. This one, you get answers and then you connect the dots on the other side. This one, you fill in stuff at the bottom. Okay, so 1, 2 for you. We have 1, 2, 1, 2. Here. Oy, oy, oy. Okay. We have connect the trig dots. Connect the trig dots. Alrighty. Let's see. 1, 2, 3, 4. Pass them that way. 1, 2, 3, 4. Okay. Pass this over. Pass this to you. There's 2 different ones. Okay. All right, now, here we go. Which paper do you want to pick one from? We can pick one from either one or one from each one. Which one do we want to pick? Anyone?
One from each.
Who?
Something from each.
Okay, something from each. All right. Which one do you think looks hard?
I think number 17 is the bottom.
Okay, 17 looks hard to them. 17 is 1 minus secant squared x minus tan squared x. And this looks like this. Okay, now, in my brain, I've got my Pythagorean theorem guys here. Think of your 3 Pythagorean theorem guys. So, I'm thinking I got sine squared theta, or sine squared x plus cosine squared x equals 1. I got tan squared x plus 1 equals secant squared x. And I got 1 plus cotangent squared x equals cosecant squared x. Well, you know what? I know that secant squared x equals tan squared x plus 1, right? So could I write 1 minus, and in here I'm going to write tan squared x plus 1 minus tan squared x. What did I do? I substituted in secant squared x. For secant squared x, I substituted in tan squared x plus 1. Okay. Oh, wow. Look. 1 minus, what do we have in here? I have a 1 in there. What's 1 minus 1? 0. So 17 goes with O. So 17 goes with O. 17. Ooh. So does there need to be a line like 17 to O? Is that what we're supposed to do? Simplify the, well, read. Simplify the following expressions and match them with their solution. Connect the number of the question with the letter of solution. We got this. So we go over here. 17 to O. Yay, team. We got part of something. Okay? Okay. So that's what we do. Okay. Now, so we connected. Now we're going to look at one of the other ones. All right. I think it's the same sort of game. Okay. Which one do you think looks hard here? 12? Okay, somebody thinks 12 looks hard. Is it really though?
I just said a number.
Okay, let's just quick look at 12. What's sine squared theta plus cosine squared theta? 1. Okay, and what is tan squared theta? Okay, look at this. It says tan squared theta minus secant squared theta. Right, -1, because if I move this over and I move 1 over, I would have -1. Okay, so -1 times 1 is -1. So 12 goes with x. Okay? I think these aren't that hard. Okay? I think you're smart enough to do this. Am I mistaken?
No.
Okay. All right. Now, if any of your band buddies run into you, tell them that it's really not that hard. If they watch the video, they can do this. Okay?